Okay, so yesterday was the second. We had a list of challenges. We're going to go over Roman numerals. And since I love hearing from you guys, I'm going to ask Megan, what's the first thing I should do now that I'm on the Quebec Platoon Roman numerals challenge here?
Have you already copied the code?
I have not copied the code.
Okay.
Well, I might have from a previous.
Oh,
let's
click
assume
on
I'm
the
starting from
Python
scratch.
one.
Yeah, let's assume I'm starting from scratch.
Okay. Do the Python one and copy the code.
Uh,
or just go over to code and click copy it.
Okay, but there's one step we need to do before that. So remember?
Oh, fork it.
Yes, we want to fork it because if I did code it down or copy this, I would still be able to get the code, make my modifications. But the issue would be when I try to go submit, or when you guys try to submit, you'll get blocked because we've specifically said you have no right access to Quebec Platoon because again, we don't want you modifying our curriculum. But yes, so that's why we fork first so that we can have it in our own world. We can make whatever modifications we want, and it'll all go as according to plan. So yep, forking is step one. And then I think you had the second step correct. You want to grab the code here.
Copy the code.
And copy that code. Do you remember the command we run?
Git clone, or actually you have to find the folder first if you're, you're in it though.
Yep, yeah, I put all mine in code/Quebec challenges. But yep, always good to have your challenges in one place. But yeah, git clone, I think you said, right? And then what do we do next?
Paste the code.
Yep, so we paste the link that we just copied. I might have copied this like a couple days ago, so I'm just gonna give it a new folder name. I'm gonna call it Roman num. So let's keep it short. So I hit enter, it cloned it down. Again, I put into this folder, so I do an ls. Notice I have this new folder here because I copied that down, I guess, when I was going over JavaScript. But Roman nums is the folder I've created. So I'm just gonna do code Roman nums. That should bring up a VS Code window in the next 2 seconds, maybe. There it is. But yeah, so we're just been going over all these steps just to make sure you guys are familiar with them. I know it gets kind of redundant going through these steps, but we'll eventually be masters at it. All right, cool. So that is my VS Code here, opened in my Roman nums folder, workspace folder. We're going to be coding in Python today. So I'm going to go into the Python folder. Let's check out the files that exist here. My computer's lagging a little bit. All right, so it looks like we have two files. We have Roman numerals spec, which is essentially our test cases. Now notice that these aren't really exhaustive, right? We have 3 simple cases that test like the I numeral and the V numeral. We definitely should probably add a few more test cases if we're being thorough about this. We're like, hey, let's test what's the value of 153. I don't actually know offhand, but that's maybe a test we want to add. And then we have our main logic file where we need to add our logic here. All right, so let's get at that. First thing, let's read the README, make sure we understand what our tasks are. So this window will go away, there it is. All right, so first, again, we highly recommend pseudocoding. I know this sounds kind of trivial, like, oh, I can code without it, but we want to get you in the process of developing your game plan mentally before you even start coding. Now, the benefit of this is, especially for interviews, you don't want to start coding right away and then realize 20 minutes into it that you're going down the wrong path, or maybe you misunderstood the requirements or just didn't fully think things through and your design has completely changed. So always take a couple minutes and just try to mentally or even physically write out your steps that you would just in plain English. So again, when I talk about pseudocoding, that's just let's say pretend you're trying to explain the process to a 10-year-old. How would you describe what you're about to do to a 10-year-old? Again, that should not have any programming lingo in it. It should just be like, hey, we want to compute the value, or we want to add up all the values inside of our list collection. All right, so we need to go through each item one by one, have something that stores the sum, et cetera, and then you could translate that to code. All right, but in this case, the pseudocode has been generally written for us, so that's a good starting point. We're going to start with lazy Roman numerals. So we want to basically given a number, convert it to the equivalent lazy Roman numerals. So when we talk about lazy, that means for a value of 9, we could accept VIII. Now that is not traditional Roman numerals. We'll get to modern in a second. But let's code this up and try to see how this might be designed. All right. So going to my toRoman function. I'm going to get rid of that comment. And let's start coding here. I don't know if we talked about the pass keyword yesterday. Did we cover this?
I don't think so.
No? The pass
No.
keyword is specific to Python. It's basically a placeholder. So you might see this in some code that we've pre-written for you. It just means we specifically have no logic here. Now, this is different than just having an empty line or a comment. This would actually be a syntax error because your function needs at least one line in it. Notice that there's this red squiggly here. That's just, if I try to run this code, I get an actual error saying, let's actually just see that run. So if I try to run my spec file, so let's do Python, what is it, Roman. Oh, I need to be in the right directory. Always make that mistake. Python. And then I'm going to run Python, Roman, numerals, spec. Notice I get an error. It's saying, hey, there's nothing valid here. So the pass statement just says, hey, we purposely are doing nothing. It's kind of like a no operation or no op, if you're familiar with that term. So if I run this now, well, my two Roman's doing absolutely nothing, which is fine. This will run, but obviously not pass the test cases. So I get 3 falses from my spec file because it was checking the value I got from my function versus the expected output. All right, so let's actually code this up. So pass statement, again, just a placeholder, meaning nothing's going on here. All right, so we have 2 Roman. Let's try to devise a game plan here. So I'm going to take this kind of step by step. I'm going to right now, my goal right now is just print out single digit numerals. So I'm just going to print out the i's for a random number that I come up with. So let's say num is going to be 17 for my example. So I'm just going to hard code it right now just to kind of get something going. Or I could actually call my function here, so that's probably better. It's called 2 Roman with a value of 17. And I want to print that out. So we'll add the print statement, which is the same as console log. All right, so we're going to get a 17 fed into our function. Right now, my goal is going to be print out just single digit numerals. So the way I think I could do that is if I just did a for in num, or range of num. I want to use that handy range function. So again, range will create essentially a list. It's actually a range object, but you can think of it as a list that goes from 0 up to, but not including the value of num. So this makes for loops, setting the for loop range really easy. And for this, I want to maybe, let's say, we want our final value to be Roman. Roman num will be empty string to start off with. And then let's say we're using our increments. Current increment is going to be 1. And then Roman 1 is going to be I. All right, so I'm just doing this just for I. I want to convert this, my decimal number, to single digit Roman numerals. So in this case, I'm going to run a for loop. So maybe comments we could run a for loop to see how many times our increments. Actually rethinking this now that I'm typing it, so probably pseudocoded, and it should have pseudocoded in my head a little better. So how many times our increments goes into our number. All right, so actually I don't even need a for loop. All I'm going to do is take our original number, let's say copies equals num divided by increments. I don't know, did we talk about this operator? So this is special. This is special to Python. I could do a simple division operator here. Divide will give me the integer or integer equivalent of that. So if I had something like 5 divided by 3, that would give me obviously some remainder, because let's actually just see this, what the values are, because why talk about it when we can actually show it. So let's do 5 divided by 3, and then we could do 5 divided by 3. Let's see what those two give us here. So I'm going to comment my function call here. Hopefully I have no syntax errors there. Let's just run those 2 lines and give it a go. So Python Roman numerals.py. All right, notice the first result gives you the actual decimal division, right? Because 3 does not go into 5 evenly. It's going to be 3 goes into 5, 1.6666 times. The double slashes means give us the integer division result. And it always rounds down or closer to, rounds down. So in this case, it just takes the 1 and chops off the rest of this. And sometimes that's useful. That's what you want. You only want the whole integer part. You don't want the fractional parts. So again, if we did something like, 10 divided by 3, let's just see what that would give us. So again, if we want to know exactly how many times 3 goes into it and don't care about the remainder, we use the double slash sign. Again, that's specific to Python. This does not exist in JavaScript. There are other ways you could get the same result in JavaScript, but again, this Python makes it really simple, like easy to do this operation, which is just another quick way in Python that takes a little more effort in JavaScript and other languages. I saw a hand raised. All right.
Oh yes, sorry, that was me, but you already answered it. So
okay, cool, great. All right, so in this case, I'm going to do that double slash sign because I want to know like how many increments go into this number. I don't care about the leftover at this point. So given copies, let's print out how many copies we need of this numeral. And then we want to update our Roman num. So I'm gonna do a plus equals. Hopefully you guys understand that shortcut notation. If not, definitely please ask. But this is basically adding a value onto Roman num. So in this case, we'll print out increments a certain number of times. So we could write a for loop here. So if I did a for loop for, I'm going to add some new syntax here just to kind of talk about it in Python. In range of copies. What is this thing that I'm doing right here? This is like an empty variable. If I don't want to use this variable, normally we'll put I here because I is going to go from like 0 to some number. If we actually need to use the value of I, well, great, we'll have the value of I there. But if we don't need that, then we can omit that. So if I do Roman num plus equals my Roman 1 in this case, that is the Roman equivalent, I'm just going to keep appending this numeral as many copies as I need to. And copies represents how many times my increment went into that number. So if I do a print here for my Roman num, that should be my result for this particular problem that I've created, where I just want to use one increment and nothing else. So copies. Any questions what I'm trying to accomplish here? I want to make sure I'm not losing anyone. All right. So if I ran this like with the value of 17, I would expect I would see 17 I's on my console because I'm only using that one numeral. So again, just running through my steps, I have some constant values, and then I'm determining how many times, I guess it's not a loop, determine how many times our increments goes into our numbers. That's why we're dividing and taking the whole number. We don't care about the fractional piece at this point. So copies in this case, let's see, 1 or 17 divided by 1 should be 17 if I did that division correctly. So I should see 17 nums right here. So let's give this a run and verify that, or see if that's incorrect. So if I run Python Roman numerals pi, all right, there we go. So I know it's hard to count, but I'm going to trust that 17 copies. And then I got 17 copies. I got a none because I'm printing out the value right here, but my function is not actually returning anything. So this none type is equivalent of null in JavaScript. So again, just different syntactically, but they mean the same thing. So none, capital N, none, is a data type in Python, which means literally nothing. And that is what I'm returning from here, because notice there's no return statement in my function. So this print statement on line 19 is going to print out none because it got no return value. All right, so this was easy. Obviously, this is our final goal, but I printed out 17 I's. What if I want to introduce another increment? So again, just take it step by step. What if I say I want to deal with tens? All right, so my next increment is going to be 10, Roman 10, that is an X. So now we want to incorporate X's and I's for my input. In this case, my input is 17. So let's just comment that so we don't forget 17 All right, so, well, how do we now get X's and I's into this? So generally we want to divide by the largest increment first, right? Because if we divide by the smallest, that's going to eat up all the pieces like bit by bit. In this case, I want my largest kind of like chomper to chomp off as much as it can and keep going until it can't equally or evenly go into the remainder that's left over. So what I mean by that is I'm gonna do the same thing I was doing before. So copies tells me how many times 10 will, how many times 10 will go into num evenly. That's what the double division or sign is doing. It's gonna give me the whole number equivalent. We'll also want the remainder. So remainder num equals num. If you remember your modulo operator, you probably use this during your pre-work challenge of, what was it? The Quebec Platoon challenge, where you need to print out certain values based on the line you're printing on. So increments. So this will give me the leftover, the whole number of leftover stuff. So if I'm doing 17 divided by 10, this should give me a value of 1, right? Because this will chop off the decimal points. This should give me a remainder of 7, right? Because we have 17, we subtract 10 from it, that gives us 7, and then we can't subtract any more 10, so 7 is what we're left with. Let's make this 27 just to see that a little better. So if we change to 27, we should get 27 minus 10 equals 17. 10 can still go into that, so we'll get another 10 out of it, and we still get left with 7. So this modulo operator won't change between 27 or 17. Obviously, a number of copies will change. So in this case, 10 goes into 27 twice exactly, and then there's stuff left over. So here I'm going to copy what I had here, put this over here. So this, I want to figure out how many times I need to add Roman 10 to my final result here. And then my remainder number is what I'm going to deal with next. In fact, I'm just going to rewrite my number. So I'm actually going to reassign to number here. There might be reasons I might not want to do that, but in this case, I don't need my original value at any point, I don't think. So I'm just going to overwrite it with the remainder so that I could use num again here. I mean, I could create a new variable, wouldn't hurt, but in this case, I think it's excessive. All right, so just to walk through what we're going through right now, we're starting with 10s, figure out how many times 10s goes in evenly into my original num. Then I'm going to append my Roman numeral variable with x's, as many x's as I need to, using a for loop. And then I'm going to get the remaining remaining bunch or remaining bits from the operation. So 27 modulo 10 will give me a value of 7, like we just talked about. And then we'll go down to doing what we're doing before, using that 1 increments or the i's. So if I change my code to this now, caps lock it looks like, I would expect I should get x, and then 7 i's after that. Would you guys agree? Disagree? Any thoughts there?
Question, you're redefining increment as 1. Is that going to throw any errors?
Great question. So in Python, there's kind of some ambiguity between creating a variable and assigning to it, meaning right here, I've actually created a variable. This is actually not going to recreate a variable of the same name. Now, this is different versus JavaScript, right? If I can get into a JavaScript file quickly, if I did something like, let inc equal 10, and then I try to do another let inc equals like 1, this would be an error because you're trying to recreate the same named variable in the same scope. That's not going to let you do it in JavaScript. But yeah, in Python, we don't use those let or const keywords. So Python just knows the first time it sees it, all right, it's going to be like, all right, we need to create your variable for you. The second time that it sees it, it's just going to be like, okay, you're just overwriting your variable. You're not creating a brand new variable.
Okay, got it. Thank you.
No, great question though. That is a key distinction between JavaScript and Python. But yeah, we're just reassigning our variable. That should be fine. All right, so I'm just gonna give this a run. Let me actually return my Roman num. That's what we mentioned want to do, and we'll print it out right here. All right, so I'm gonna run that. All right, notice what we got. That is what I expected. I got XX and 7 i's. So we're building this Roman numeral slowly, but we're getting there. But let's take a look at our logic. Any questions about what I accomplished here? Please ask if you have any questions. Copies was from this only. I guess I never got copies value above. But I'm just going to delete that. Okay, let's continue on. So we've taken baby steps here where we got, 2 increments going, but we actually want all the increments, right? We have I, V, X, L, C, D, and M are the ones we need to worry about. Well, one way I could solve this is I could just copy and paste, this block of code and update it for, 20 or what is it, 50, and then also 100 and 1,000, whatever increments I need. Because that's what I did, the first time I had ones, and then I adopted that, modified that for tens. So I could do that. That's going to work, but that is not proper coding in terms of anytime you catch yourself writing the same thing or similar things over and over again, you should try to think, how can I condense this or reuse this logic rather than kind of copy and pasting and having, 12 different sections for 12 similar cases. So this is where we want to, be kind of thoughtful and say, all right, we don't want to just copy and paste and keep, adding to our code. How can we kind of pick out similar pieces between this block and this block and make that generic so that if we have, 7 new increments or 20 new increments, we don't have to write, 20 new chunks of code. Our code should be able to adapt pretty easily. So looking at the similarities here, notice we're doing the same computation. Copies equals num divided by increment. We also have this for loop that is more or less the same. It uses a different numeral value, but it's still the same for loop. And then we do need to get a remainder each time. So it seems like, again, repeated items. And to me, when we're doing something repeatedly, that screams to me we should be using a loop. So in this case, the question is, do we need a for loop or a while loop? And we talked about for loops are usually good for when you know how many iterations you can do. While loops are good for kind of unknown iterations. Here, it's not quite so clear. Like, I don't necessarily know how many iterations might be done by these loops, but I should know how many increments I have. So I'm thinking we could use a for loop because we have a set number of increments we need to go through. So I'm going to create a for loop here. Let's just use I for now and range. And then we need something to range over. So right now, I don't know what that is. So I'm just going to leave that blank, which is not going to be valid syntax. I'm going to move my block over here because this is what I wanted to repeat essentially. And then I'm going to get rid of this block here. All right, so we want to do this sort of repeatedly. But remember, the one different thing here was Roman will be different and increment will be different based on each loop you want to do. Sometimes it'll be 1,000, there'll be 500, 100, all the increments that we're going through right here. In fact, I'm going to copy this over because I don't memorize these numerals. So let's drop them somewhere here. All right, good reference there. All right, so we want to start with M because we want to start with the largest increments. In this case, M is 1,000. And then the next increment should be D. Now, I don't want to hard code these, right? I could, but generally speaking, we should have this be a little more dynamic. So if we add a new increment, we don't need to add too much more to our code. So we should probably have, I'm thinking, some data structure that tells us, what increments we have and kind of the equivalent Roman numerals we have. So I'm actually going to create a data structure here. Let's create, I'm thinking, a list. So let's say conversion Roman lazy. Hopefully that's a good enough name because we're doing lazy Roman numerals. And then I want to add some entries in here. So the reason I chose a list was because I want to go in order, right? I want to start with 1,000 and then go to 500. So lists, if you remember, are ordered collections versus dictionaries are not ordered. So in this case, I chose to use a list. Let's create a mapping. So we need to create some relationship between 1,000 and M. So I'm actually going to create a dictionary inside my list. So we're getting kind of a little more complicated here, but this is what makes sense to me. So I'm going to go with, call it decimal will be 1,000, and then Roman will be M. All right, so I've created a list, and each one of those list entries is going to be a dictionary. This is not JavaScript, so we need to surround these in strings. All right, so there we go. That's one entry. I'm going to add a few more entries to map out all of my possible increments. So I think we have, what, 7 of them, if I count it correctly. We got a comma there. All right, so I think I have 7 here. So I'm going to update these with the correct values. We have 500, we have 100, we have 50, we have, what that's 10, 5, and 1. All right, and let's make sure we update this. Let's tab these out to make them easy to read. What do we have? We have M, D, C, L, X, V, and I. Again, the reason I put my largest one first is because I want to start dividing by the largest increment first. So that's why, again, ordered collection, this should be the first entry that I encounter if I'm looping over this collection. Andrew, you have a question?
Yeah, just to make sure, since you have the brackets around each one, don't you currently have 1, 2, 3, 4, 5, 6, 7 dictionaries in there?
Yes.
Not one, right?
Correct. Yes. I have
Okay.
7 small dictionaries for each entry. Now, there are other ways to go about this. I know I've done this with lists of lists, but to me, this is going to be the most clear. So if you solve it with a different data structure, that's fine, so long as you can justify why you decide to use that data structure. Yep. In this case, I have a list, and each list entry is a dictionary. So I have 7 dictionaries here. I saw a couple hands up. Katarzyna?
I just have a question about, I found something called an ordered dictionary, like ordered dict in Python. Is there a difference between using that and using, or like, is there a rationale for using that instead of like an array of dictionaries?
No, great. Kudos to you for kind of looking up additional advanced data structures. So yeah, ordered dictionary will give you kind of the benefits of both a list and a dictionary, where we talk about lists are ordered and dictionaries give you the key mapping pairs. So ordered dict is a more advanced data structure, which we didn't cover, but it is good that you look that up, and you could probably use this. So if you're curious about this, you definitely get to Google and see how you can use this. In terms of which is better, I'm sure ordered dictionary gives you a lot of benefits. Like it probably has a lot of functionality in it. But I guess in this case, I'm just going to stick with a list of dictionaries just because those are our basic data structures. But no, that is great that you looked that up. And if you're able to solve it with ordered dictionary, nothing wrong with that. Absolutely not. Okay, so now that I have my data structure here, let's actually incorporate that in my loop that I was trying to go through. So remember, I didn't enter a range value. Well, now I could do a range of len conversion Roman lazy. So I have a list. I'm getting the length of it via the len function. That's how you do it in Python. And I'm taking a range over it. So I can do it this way. But that's, now I get the index back, and then I got to go back and get the index within my list. That can work, but the syntax gets a little less nice. So why don't I just go through my list in the first place, right? Instead of getting the index value for my list entries and then going back to my list and getting the value at that index, we can just use a for loop in Python like this, where we'll get this dictionary will be the value of I. And I should probably name I better because I is used for index. What if I name this conversion data, right? So I'm actually getting a dictionary back. So maybe call that dictionary to make it clear that's a dictionary. So for every loop, I'm going to get a dictionary back. And that's what conversion data dictionary is going to store. So now, instead of having increments and like my Roman variables, I'm going to get that from my dictionary. So I'm actually going to delete these two. And increment, I've renamed that to conversion dictionary.decimal. I actually kind of wish I named this increment, so I'm going to go back there. Sorry for the switcheroo. I want to keep it somewhat consistent to what I had, so we'll call that increments. Just a naming thing, again, doesn't really matter. All right, so now that I call it increment, I can put this back to increments. Wish I kept my comment. So figure out how many times our increments goes to our current number. All right, so that's what this operation is doing. Num is what we passed in, so that doesn't change. Copies still needs to exist. We're going to do a for loop, and now we're going to append conversion data dictionary dot Roman. So that is the Roman numeral that we are dealing with right now, and then we need to update this. So again, this will be our leftover. What part is left over? Andrew, you have a question?
Yeah, so you're using, do we have to use the dot notation or bracket notation?
Good question. I think dot notation should work. I'm not sure if I'm getting confused between JavaScript and Python, so let's find out. Always doesn't hurt to try it out. So just make sure I have my logic in place. So we're going to loop through my entire list, find out increments, use a for loop to append to Roman numerals, then get the leftover or the remainder of the operation and do this again. And then once this loop completes, Roman num hopefully should be correct. So let's stick with 27. So 27 is our input. In Roman numerals, that is what? XXVII, I believe. So XXVII, that's what I'm expecting. In fact, let's test it out before we write test cases. So bring up my terminal. Let's see what we get. We get an error. Oh, maybe you're right. Maybe I do need square brackets here. Always hurts going back and forth between JavaScript and Python. I'm sure you guys have dealt with that. All right, so let's use square bracket notation. Thank you for pointing that out. Got another error. So dictionary objects has no attribute Roman. Oh, forgot this one right here. Good catch there. Glad you are getting to know Python. All right, so we need to use square bracket notation. That notation is only for JavaScript. Good lesson there. But now that we are accessing these values, let's actually see if we get XXVII is what I expect. All right, cool. I think that's exactly what I got. So again, we started off kind of just like doing it piece by piece, but eventually once we got to the point where we're writing the same logic over and over, always kind of, if you catch yourself copying and pasting code a lot, think about how that can be repeated within a loop rather than you manually having to repeat it each time as a developer, right? Because if I actually, did it the first way, I would have 7 different sections for 7 different increments. And if I had to add an 8th increment, right, like whatever, 5,000 might be, I don't know that offhand, but if we have to add 5,000 in here, currently we could just add 1 line here and it's going to work. Versus the other way, we'd have to copy and paste more additional code, and that's going to increase the bulkiness of our code again, and also makes the chance for bugs getting added in there higher the more code you add. Yilin, do you have a question?
Yeah, Anchor. Just want to make sure, is it for the naming of the object? Do you need to use snake case?
Yes, I do. Yilin, thank you so much. Yes. So again, going back and forth, I did that also. Conversion, I didn't even spell that correctly, did I? Typos and bad cases. Thank you for pointing that out. Yes, when you're in Python, you want to use snake case. So Roman lazy. I'm glad you guys didn't let me get away with that. So thank you. Let's call this data. All right, while I'm correcting that, Marcos, you have a question or a comment?
Yes. So yesterday when I was going through one of the problems, I was trying to implement a counter outside of the function, and it wouldn't let me use the variable that I defined outside of the function without using the keyword global. I see you're doing that here though with your list of dictionaries. So what's the difference?
Great question. So what Marcos was saying is, let's say I have some global value out here equal, let's just say that's going to equal donuts. If I want to use that global value in my function, I can. So let's actually print the value of global value here. All right. So again, we're going to see a random donuts in our output. Hopefully that won't throw you guys off what we were doing initially, but notice we get donuts. So we have a value outside, which is a global variable because it has no function scope. It's not inside of any particular scope. But then we are able to access it and use it in our function. This is fine. What Marcos was saying, and he's totally correct. What if we want to modify the value of global value? Well, we have access to it. So I should be able to just do global value equals bagels. I can spell bagels. And now I should expect, maybe let's do this a little differently, in function, and do a print out here, print out of function. What call it, global global value. These tooltips are driving me insane. All right, so global value. So what I'm trying to do here before we run this code is I create a value outside my function. I want to print it both inside my function and outside my function. All right, so notice I have an error here. Let's see what it's saying. Oh, bad syntax. Okay, so I would expect that if I'm modifying my global value inside my function, I should see bagels right here and bagels right here because I call my function first, which updates. Let me try to get this all on one screen. So in my function, I update global value to be bagels, print out inside my function, and then after my function completes, I also print out global value, which should be bagels, looking at my logic. Let's actually run this and see what happens. Clear, run Roman numerals again, even though we're printing out bagels. Notice it's donuts outside my function. It's not actually bagels. Now the question is, well, wait, I updated my value of bagels here. So why is it I'm not printing out bagels down here? Now the answer to that is kind of what Marco has mentioned when he was talking about this. What's going on here is you have a variable out here called global value, and you have a new variable inside the function also called global value. You actually have two variables. This is a new local variable. This is a new global variable. So these have the same name, but they actually are independent variables. If you want to update the value of global value, you need to add the global keyword. So you would do something like global value. Now this global keyword says you actually want to use this value, not create a new one. I know we didn't go over this too much. Again, usually you won't be using global values, but if you actually want to just use it and not create a new variable, now we are, let's say this says use variable from outside instead of creating a new local name variable. All right, so now this global keyword says, hey, we just want to use it. We don't want to create one. So if I run this now, this should update the global value of bagels. So I should get bagels here, and I should get bagels here. Let's actually verify that or see if I'm lying to you. All right, notice we get bagels inside the function and bagels outside the function. And the whole thing is, Marcos is absolutely correct. If you want to update a value, you need to use the global keyword. But in this case, we're not updating our conversion Roman lazy array, sorry, list, because we're only reading from it. We're not writing to it. So that in this case, it does work without the global keyword. We're just reading the value and not trying to modify it. Marcos, does that answer your question?
Yes, it does. Thank you.
Okay. Did I confuse anyone with that explanation there, or you guys kind of understand? Again, you won't be using this very often, so yeah, we didn't cover it, but it is possible to do what we just kind of showed here, where you can modify a value from outside the function. Any questions about that? Joseph, I see you have your hand raised. Is it about this or something else?
It's kind of about this.
Okay.
I was wondering in the print functions, why is it treating the in function as part of the function and not trying to treat it as a string?
You mean right here?
Yeah.
Yeah, so the print function can take in as many values as you want. So I'm basically printing a string and then printing a value separately. I'm not string interpolating here, to be clear. So that's why the comma, I'm passing in two values. I can pass in a third value of, yummy. So the print function is just flexible, where you can take as many values as you want, and it's going to print them out as strings. I'm not sure if that quite answered your question, so I want to make sure I understood it correctly.
Not quite. So
Okay.
that one's in function, and then the second one is out of function.
Yep.
Yeah, so I guess it is trying to print it as a string or treat it as a string, because I see below now it says out of function. So I guess I just misread.
Okay, gotcha. Yeah, I should make my terminal larger. I think that's going to be my settings. Sorry, give me one sec. I think I modified my settings. All right, I'll have to do it later. But hopefully you guys can see it down here. Yep, out of function, print out bagels. So again, that was a quick detour about the global keyword, but good to know about in case you are going to deal with it. Courtney, you have a question?
Can you go over the conversion data? Like, maybe can you print that for me so I can see how that's changing each time?
This conversion data? Sure, absolutely. So conversion data, VS Code. So again, we have this list. So let me highlight this list. So this is a list. Within that list, we have 7 entries. Each entry or each item is a dictionary. So it's a list of dictionaries. Again, there's no limit to how many like embedded data structures you can have. You have a list of lists of lists. You can have lists of dictionaries with lists in them. But in this case, each conversion data should be one, excuse me, one item from my list. So yeah, we should definitely print it out. Let's actually label it too. So this is in loop conversion data. Make sure we know what that is. Clear my console. Let's give some more space here. Let's run this. All right, let's see what we got out here. So every time we're in our loop, we get a new dictionary from our list. So the first time, increment's going to be, the dictionary is going to be increment 1000, Roman numeral M. So we're going to use those as our increment and Roman values, and then do the operations that we're doing, where we figure out how many copies we get, as in how many times the increment goes into it, append into our Roman numeral, that's our final answer, and then we get the remainder. So the next time we're in this loop, it should be the leftover part. Num is changing each time. Again, hopefully I didn't confuse anyone by updating our initial value. So yeah, we get 27 initially, but num is not always going to be 27 in my function. Now, again, I could have said Newnum equals num just to not modify initial parameters. And sometimes that is good practice, that you don't want to modify your initial parameter value just because you might need to reference it. So in this case, I could create a new value if I need to. So now new num's the one changing. Num's always going to be 27. Again, I might have a reason for keeping num the same. Yeah, did that answer your question, Courtney?
Yeah, definitely. Thank you.
Okay, cool. So, all right, let's actually, I think we have a good solution here. Let's actually test it out by writing some test cases. We don't have to get too wild here, but let's call in a few people here. I've heard from some of you guys today. Let's see. Roque, can you give me a favorite number from 1 to 3000? Just a random number or a favorite number?
All right, 1254.
54. Oh, you stuck in that 4 there. All right, so I need to look this up because I am not a Roman numerals expert. So let's just find it. 1, 2, 5, 4. Keep in mind, we're doing lazy Roman numerals. That's one thing I need to point out. So it looks like it's MCC L III. MCC L III. Is that right? MCC L III. So again, this is the lazy version, so we don't get that kind of IV for 4. So this should change to III. Let's get one more number in here. Marcin, can you give me a random number from 1 to 3000?
2,890.
2,890. All right, great number. My computer is lagging. Oh, I want to go to Roman. MMDCCXC. I'm not sure how to convert that to lazy. MMDC. All right. Computer's having a bad day. What was it? XC. So that should be, I think, 4 X's for lazy. All right. So this is, we need 2000. D is, what is that? So 2000, D is 500. So that's 2,500. Then we have add 300. So that's 2,800. And then we add only.
Yeah, L, I think.
Am I forgetting D? L, thank you. Yeah, so Roman numerals, especially lazy ones, they're not used very often. So, okay, assuming that we did our mental conversions correctly, let's actually run our spec file and see if this gives us what we want. So I'm going to do Python numerals spec, not py. Oops, let's get rid of extraneous. So this print statement can go away. That print statement can go away. Okay, hopefully I have no more print statements left around. All right, well, let's clear this, run it. All right, there we go. We got 5 trues. So I think that, again, we should probably test this a little more exhaustively because, again, we're not, targeting L and C or V often enough, but I think we have a good solution here. So now let's go to the next step in a few minutes that we have. We did the lazy case. Great. How do we adapt this for the modern case? Right, the modern numerals where instead of writing for 4, for example, the lazy way is I for 4. The modern way is we do IV. I think the official rule, I don't know how official it is you should never have 4 numerals repeating in Roman numerals. So in this case, if you have 4 I's, that is not valid. That's when you switch over to using a new increment. So you should never have 4 numerals repeating in succession for Roman numerals. So how do we solve this the modern way? Do we need to rewrite our entire logic? Is there anything complicated we need to do? I'm going to say no. There might be a more convoluted solution where you can kind of figure out, all right, I have 4 repeating items. I need to condense that down into, IV instead of 4 I's by some weird logic. That's possible, but that is not the simplest way to solve this. And I'm just going to kind of go with the simpler solution here. So if you think about it, we really just have new increments, right? Here, we're using I's, but now we have an increment for 4, in addition to having an increment for 5. So without modifying my logic at all, I can just modify my dictionary. So if I actually just copy my dictionary, just to keep the lazy around, let's call this Roman modern. Now, let's just start from the ground up. So we know what 4 is. So what if I just add a new increment for 4? There's nothing stopping me from having 4 and 5 here. So let's just put IV here, right? Because if we have 4, that increment should specifically be IV and not V, or, we don't want 4 I's. 4 should be the next largest increment between 5 and 4. Because IV is a special character or special numeral that we had to deal with. Same thing for 9. So I'm going to add a new increment for 9. Let's go here. That's going to be IX. So again, the way these work, I forget if we covered it, but you subtract 1 from 10 because the smaller increment is before the larger increment. So that tells you that's actually 10 minus 1, which gives you 9. We probably have one for 40. 40, let's get this done. That's going to be XL. So again, we're taking 50, subtracting 10, because the smaller increment is before the larger increment in Roman numerals. We got to do 90 and a couple more. So I'm just going to add a bunch of new increments here. This should be XC. I think we have a couple more to do. So we got 400 and 900. So 900 should be 100 minus M. So that's going to be CM. And then 400 is going to be 100 or 500 minus 100. So that's C. Okay. So I've just added a bunch of new increments, but here's the key thing. My algorithm does not need to change. It's doing the same exact thing with just new random increments that I threw in there. I can make up whatever increments I want. My logic, so long as I coded it correctly, should be flexible enough to handle it. And that's the whole point of, again, using a structure rather than copy and pasting your code. So now, I should be able to run this. Let's actually verify it. So Amy, can you give me a random number from 0 to 1000? That's kind of like interesting to look at for Roman numerals.
Let's see, 594.
594, excellent number. So Roman numerals, this should give me the actual one. So DXCIV. So let's actually see if that's what we get. So what do we want? We want DXCIV, if I remember that correctly. And that was 594. 594. All right, let's have our fingers crossed, but let's see if this works. But I do need to change one thing. Sorry, I need to change this to modern because I opted to create 2 dictionaries. The reason is so I can switch back and forth. I want to. So I have my modern dictionary. So I'm going to use my modern dictionary here. That's the only thing I need to switch for my change here. So let's run our main file, not the spec file. All right. So if we pass in 594, we should see DXCIV, right? So what they tell me, DXCIV. All right, fingers crossed. Let's give that a run. Notice we get DXCIV. So again, the only difference between lazy and modern is just we have new increments. The logic does not have to change at all. We just have, twice as many increments, but everything still works as before. Let's try one more, or let's add a couple more since we have a couple minutes here. Let's try these numbers, the non-lazy way. So let's just create 2 sections. Comment these out. So we switched our logic. We could make this flexible enough where we could tell it, do we want lazy or modern? Like we did pass maybe another parameter into 2 Roman, but I'm not going to go that far. But hopefully you guys can understand how that can be done. All right, let me check these numbers quickly. This was MCCLIV. So yeah, that just needs to change right here. And what was the other number? 2890. My computer is not liking me today. Roman. All right, MMDCCC. All right, so he's going to change the last part to XC. XC. All right.
And for the one right above that, you forgot the I before the V there.
Oh, thank you for catching that. All right, so let's run our spec file. Again, these aren't exhaustive test cases, but I just want to see if our modern stuff works now. So go there. Okay, cool. We got a bunch of trues. I think this is from my other file that I forgot to comment out. But I think we're looking good here. Again, if I had a little more time, I would definitely test this a little bit more. Why don't test your corner cases, like test 100. Make sure you just get a value of C out. We do that quickly. That'll be the last test I run. Let's do 100. And that should be a single increment of C. Let's run that. Yep, still passing that test case. So definitely make sure you take the time to test your algorithm. Again, no developer that I've met has written 100% correct code all the time. So always, even if you're like, yeah, this was the easy algorithm, I know it, always go the extra step of testing it just to ensure that it does actually work. It's easy to kind of overlook something, especially when you're writing your own code. You're like, yeah, I know what I wanted to do, but you might have written the wrong thing or just wrote the wrong logic. Always be mindful of testing is the takeaway here. Okay, so I am happy with my solution here. Who can I call on? Jenny Lee, can you help me get this back to my GitHub and kind of submit it back to the instructors here? What are the steps I need to do?
So you add it to the staging file, git.
Right. How do I do that?
Git add dot.
Yep. Cool. What's next?
And then git commit -m and then your message.
Okay. Completed Roman nums and Python. All right. And then what's next?
Git push.
Git push. I think we need one more thing here.
Origin master.
Yep. So again, the last part is the branch. Again, usually I leave it off because I know I ran into this with one student yesterday. Sometimes your default branch will be named main and not master. I think it's a naming convention that changed over time. So I usually just do git push origin, and that's going to determine whatever the the branch that I'm the main branch that I'm on. So it could be called master or main. I usually leave it off. So you hit enter, and that should commit it to the right place. So it did add it to my master branch, as you can see there. All right, cool. And then what's the last step I need to do, Jenny Lee?
I need to do a pull request.
Absolutely. So I'm in my personal GitHub. I'm going to click the pull request tab, new pull request. It's going to do its thing, create pull request. All right. Let's put my name so I know who did it. Encores instructor solution. We can leave Roman numerals. Let's make sure we know what we're doing. In Python. All right. I think I'm happy with that. Click create pull request. Thinking it's thinking. Got my check mark. All right. So look at my pull request tab. It should be in there. So again, if you want to look at my solution, you can go to the Quebec Platoon repository and then find my pull request or anyone else's pull request if you're curious how other students chose to solve it. So I do see 29 commits here, so that's good. Definitely want to see a few more because we do have a class size over 40. Again, no worries if you were unable to complete it yesterday. Just make sure you go through it today. Roman numerals is a good challenge to focus on. Just going to say that right now. So make sure you understand the logic, the algorithm that is required to solve it in Python or JavaScript. Okie dokes. That was nearly an hour, so glad we spent the time on that. I'm going to stop recording.